So here we go. Here's my little scenario. I have a spring. It's attached to the ceiling. And on the end of the spring, which is why it's stretched out, there is a weight attached. Okay, W for weight. Now, this weight is stretching out the spring, and at the moment, it's not going anywhere. Okay, so this is where it's at rest, if you like. It's not moving. So I'm going to call this point x equals 0. Okay, I'm just going to define it. Remember, with these motion questions, we can define x equals 0 wherever we like, right? But being that I don't know how long this spring is, the place where it is right now seems like as good a definition as any. Okay? Alright, now, I'm going to give you 3 questions to do with this, and you'll see how it relates to functions of displacement. Okay? What we're going to do with the weight is lift it up 2 meters. Okay? So, the weight is lifted 2 meters. Let's just assume, one-dimensional movement. So 2 meters directly above x equals 0. Okay, and then it is released. Okay, so you can see the motion of this object is obviously going to be governed by gravity, also this spring and its elasticity and that kind of thing. So let's just assume, okay, that its movement after that point is defined as its acceleration being minus 4x. Okay, minus 4x. So you can see it's about the force acting upon this weight. Okay, is dependent on, okay, how far are you from where you started? Okay, minus 4x, right? So it's in terms of your distance from x equals 0. Okay, so far so good. So here are my 3 questions. Okay, can we get velocity as a function of displacement? Okay. First, velocity. Secondly, can we show that this weight is going to be stationary 4 meters below where we dropped it? Okay, so you can work out the x value for that, which is not too difficult. Lastly, can we work out the maximum speed? Note that it's speed, not velocity. What is that maximum speed, and where does it occur? Now, you can see, just because of the way that this is all phrased, right? Velocity is a function of x. Show that it's stationary at this place. Show that, or find the speed and where it happens. So it's all the question of not when. There's no time in this at all in this system. Okay, there is, but we're not interested in it. Okay, we're just interested about positions. So how do we go about solving this? Well, we're going to use this result. Okay, let's just assume you just proved it in part A, and this is actually part B, C, D. Right. So what you're going to do is take your acceleration function and notice that it's in terms of x, not in terms of t. Okay, so A, this is first part, is minus 4x, right? Therefore, you take your result, this one here, okay? The derivative with respect to x of half v squared. Okay? Occasionally you will see it as written with that v squared on 2 up the top. Okay? You can see it's the same thing. It's just wherever you put the actual function you're differentiating. That's minus 4x. Okay? Now, before I go any further, you can see it wouldn't have done much good to get this in terms of t, because when you look at your right-hand side, it's not in terms of t. So you can't integrate with respect to t, because what useful result are you going to get out of it? But at this point, left-hand side in terms of x, right-hand side in terms of x, so I'm going to integrate. Okay? So I'm going to get half v squared is equal to the integral of minus 4x with respect to x. Okay, so this dx over here has moved over to the other side. So, minus 4x. You integrate, what do you get? Good. Okay. Now, this is an indefinite integral, right? We're going to use our initial conditions in a second to actually work out. But instead of writing my constant as plus c, I'm going to write it as c on 2. Okay? Remember, the constant's anything you like, right? You'll see in about 30 seconds why I wrote c on 2 rather than just plain old c. Okay? Now, I want to work out what that c is, what the constant is, okay? So you can see here, just to make things a little bit neater, because I know what initial velocity is, it's implied in the way that I read the question. I'm going to get v squared, I'm going to multiply through by 2 to get rid of my half over here, right? So I'm going to get minus 4x squared plus c. Right? Now if I want to solve for c, I might as well have it not a fraction. Like why be a, or double it up, it's just simpler that way, okay? So what initial conditions do we know about this? I did tell you that at rest, it was at x equals 0, but then we did something to it. Namely, we lifted it 2 meters, okay? And I had it in my hand, or whatever was holding it, okay? So therefore, I want to know the relationship between a particular velocity and a particular displacement, right? So I'd say at, right? So now this is not going to be time equals 0. It's going to be, what's my starting thing? What's the first thing we know? X equals 2, right? I'm directly above. So at x equals 2, right? It's not moving. I haven't released it yet, okay? So that's my velocity at that place. I actually have been saying initial, which is a bit naughty of me, because it really doesn't have to do with where you start. It's about where you are, okay? But it's just in the way we talk, it's like, okay, this is where I begin. So now I just substitute in to actually evaluate my constant, right? So you get 0 equals minus 4 times 4 plus c. So there's my constant. Okay. So this answer here, A, it's a bit sneaky. We're going to get to what happens later when we need to get rid of the squared. Okay. But I'm going to leave it at, this is my answer for A. V squared is minus 4x squared plus 16. Okay. Getting rid of the squared and taking the square root is a bit tricky. We'll deal with that later today, hopefully if we have time. Alright, now, next question. Show that this weight is stationary 4 meters below where it was dropped. Well, that's not too hard. 4 meters below where it was dropped. It was dropped from x equals 2, right? So 4 meters below that is x equals minus 2, right? So at x equals minus 2. V squared will be, it's just a straight substitution, yeah? So I'm going to have minus 4 times minus 2 squared plus 16, which is minus 16. And there's actually what I was asked to show, that it's stationary, right? So I would say at this point, as required. That's the result I was after, okay? So not too dramatic, right? Now let's finish it off. What is the maximum speed and where? Now, I know when you hear the word maximum, you sort of, like Pavlov's dog, we trained you to think, okay, maximum, differentiate, find a stationary point, that kind of thing. But I want you to look carefully at the equation of velocity, or actually velocity squared, okay? If I'm trying to work out, okay, now, you can differentiate, it's fine, but there's a much simpler approach. If I'm trying to work out the maximum speed, what's it going to be? How would you go about thinking about it? If v squared is, I'm going to turn the order around, maybe that'll make it a little clearer. If that's my velocity function, my velocity squared function, where's the maximum? When, now see this, right? X squared. Obviously x squared is it's going to be positive, or the smallest it can be is 0, okay? So I'm starting at 16 and then I subtract whatever this is. Okay? So as I get further away, this thing is getting bigger, right? So 16 minus that is going to be less and less and less, right? So what I actually want is for this thing to be as small as possible. And the smallest it can be is 0, right? Because x squared is always going to be that. Think back to inequalities, right? So therefore, maximum velocity, okay, what's it going to be equal to? It'll be v squared equals 16 minus 0, right? 16. Okay, now we were asked just for speed, right? So that means come in irrespective of direction. Okay. Thank you. So, I'm basically there, right? Maximum speed, therefore, is 4 meters per second, because I'm not interested in whether it's going up or down, I'm just interested in how fast it is. Now, where does it happen? Where does that happen? Well, we actually sort of already answered that, right? It's when 4x squared is equal to 0, which implies x is equal to 0, right? This occurs actually at that point of rest, right? Now, does that actually make sense to you, right? It goes fastest as it passes that point, because after that, it's going to start slowing down to come back towards that resting point. Okay? So, that's it. That wasn't too difficult, was it? Now, there's more to questions than this. By the way, I will quickly tell you, why would you want to avoid thinking about this in terms of stationary point? Because you can. What would you have to do to get a stationary point for that? I am going to have to get, if I want dv on dx to work out a stationary point, I'm going to have to do this, right? Which admittedly, like, okay, you guys can do, but it's just a mess, especially when there's such a simple approach to actually get the answer out, okay? So that's why, think about your equations and what they mean, and what it means to solve a maximum situation with that, and try and avoid doing that.